Good day everyone. Myself Punna Sayavanish. I am from team GT97. The total project is done on the supervision of Kirti ma'am. Now I will show you a quick demo of our translators user interface, and this is our landing page of a project which was developed by using React.js, and React is a JavaScript library used for building interactive user interfaces. And so coming to the point, there are options available for the user. One is translate text. It takes the user the manual test page where we have two boxes. In the first box of the user types are paste any English text. For example, I am entering a sample text. After clicking on the translate button, the front-end app sends the input text to a fast API backend using post request. This is the home.jx file. This is the translate page file. It sends the text to the backend API for translation using a embark model. And this is the server.js file, and it is the main part of the backend. In server.js, you can see here it is used for constant of responses. And coming to the main.py, in main.py consists of embark, which is required for getting accurate translations. This is accurate translations, and here it is used. And coming to history of translator, where we have been used, you can see the history as well. And next, coming to it is the upload file, where we can upload a text file. So I'm choosing the random file, so the file is displayed on the left side. This is the mode of the upload file, same as it translate text. In that, the user clicks on the translate button below. File content is sent to the fast API backend using post request, and in the backend we pursue the text to embark model, which processes and generates the Telugu translation, and the output is displayed on the right side box. There is a history button, lets the user views the previous file translations and stored in MongoDB and database. Next, the conclusion is this is how our English Telugu translation project works. The entire backend is powered by AI models like Embark, and it supports both direct input output text and file uploads. Coming to the major learning gain is that I learned a lot of things during this project, and how to use the transformer models like Embark, and how to build a fast API backend and connect to it in React, and how to handle PDF uploads and extract the text, and how to process large documents in parts, and how to reduce the latency, and how to improve our user experience. Now coming to challenges faced. Some of the challenges that I faced is the Embark model was slow when translating big fixes, and sometimes this model is mixed with English versus Telugu, that is the tokenizer issue. Now coming to the handling large PDFs required splitting them into smaller chunks, and there was a bugs in connecting Node.js and Python, and I fixed them with debugging. Now coming to milestone confirmation. Milestone confirmation. Here is a confirmation of what we have achieved in milestone 1. At the beginning of the project, the goals were to build and translate a system from English to Telugu using a transformer model, and to integrate it into a working web application. The translator system works with using the Embark model. The web app is fully functional and can translate both typed text and uploaded text files. Now I am going to explain about the architecture diagram. It is the architecture of our English to Telugu translation system. It has three main parts. They are front-end, back-end, and model or database. Now coming to the on the front end, the user starts on the home page, and here they can choose the translate text or upload file. And if they click translate text, they go to the page where they can enter the input text, get the output, and see the history. And while if they click upload file, they can see the original text and translated file, and also view history. And both the actions send a request to the backend using fast API and Node.js or Express. And the fast API server sends the text or file content for translation. It also saves and retrieves the translation history. If the file is uploaded, it first goes through a file upload processing step. Next, then the server sends the clean text to the MBOT model, which does the action translation. The MongoDB database stores the translation history so that it can be viewed later by the user. Now for model selection, we have been used MBOT model. This is a multilingual transformer model from Facebook AI. We choose the version fine-tuned especially for English to Telugu by a again face user named Imish. This model performs with a low resource languages like Telugu. We also consider Merton MT, which is faster but does not perform as well. So we selected the MBOT. How it works: a user enters the text or uploads a PDF file. The front end sends the data to the backend. The backend uses MBOT to translate it, and the backend results is sent back and shown by the user. This works for both plain text and files. It's smooth and easy for users. Now coming to deployment. We deploy the front end on Vercel, which makes it fast and accessible. The front end runs on back API. Here conclusion is our project is a complete English to Telugu translation system with the React.js frontend and the Node.js and fast API backend and the MBOT transformer for accurate results. It supports the text and file inputs and it saves the translation history via MongoDB and delivers real-time performance. In the future, our aim is to add speech to text translation support for more languages and mobile app integration to make system even more accessible and powerful. Thank you.